Today we've got the Sport model of the Apple Watch. The Sport model we analyzed has an aluminum case, but it also is available in stainless steel. It measures about 39 by 33 millimeters, and it is about 10.5 millimeters high. The glass display has a density of 272 by 340 pixels. You access the watch electronics by prying off the display using a razor blade. Beneath the glass display, we found a gasket, apparently there to provide some waterproofing.
The watch display connects to the rest of the electronics through a relatively complicated flex circuit that includes a serpentine conductor pattern, as you might find serving as a pickup coil for a wireless charging scheme. This is interesting because though the watch uses wireless charging, the docking takes place at the bottom of the watch where a magnet holds the watch on the charging stand. Also on the flex circuit is a chip from Analog Devices that seems to be a touchscreen controller. We say seems to be because the part number we found on the chip, AD7166, isn't a standard part number. We can only say that judging by its position on the flex circuit and according to other analyses we've seen, it seems to be doing touch control.
Next to the Analog Devices chip is what seems to be an optical sensor pointed at the display. It looks like it could be from SMS. Apple was granted a patent on this idea a couple years ago. Basically, the sensor gauges how bright to make the display. What's interesting is that it sits behind the display panel, instead of being mounted on the surface of the display, as in most smartphones and tablets. With the display and flex circuit detached, the 3.8 volt, 205 milliamp hour lithium polymer battery comes into view, along with several components attached to the case with super tiny screws. We counted 16 screws used in the watch. Specifically, screws hold the speaker and taptic engine in place. Ditto for an antenna assembly that sits on one side of the case. Another 2 screws hold a mechanical button to the side of the watch case. 2 more hold a metal door that covers a hidden diagnostic port.
To complicate things a bit, the screws have a tri-point head that is not a standard type. We had to special order a screwdriver head to fit them. Just as a general comment, screws are a relatively high-cost way of attaching components. It's unusual to see this many of them used in a mass-market consumer product. And this liberal use of screws probably didn't help Apple keep the cost of its watch down. One of the things fastened by screws is a metal bracket around an encoder wheel for the adjustment knob on the case. This bracket was a bit puzzling. There doesn't seem to be an obvious reason for it. So that part of the construction remains a little mysterious. In any event, the knob works a little like the front panel knobs found on modern test instruments. These knobs would control potentiometers in older generations of instruments. Today, an instrument knob is attached to a position encoder that provides a readout of the knob position. This is also how the adjustment knob in the Apple Sport watch works. Judging by the mirrored, multifaceted surface on the encoder wheel, the encoder is probably an optical type that reflects LED light onto an optical sensor as the encoder wheel turns, as a way to register changes in the position of the adjustment knob. And if you look carefully beneath the encoder, you see what may be a light sensor and LED that produce the encoder readout.
Near the encoder wheel sits what Apple calls its taptic engine, which provides tactile sensations in the form of vibrations to the watch wearer. Taptic engines can also be found in iPhones, iPads, and MacBook laptops. It's basically a rod that is spring-loaded at each end and vibrates back and forth in a few distinct ways to alert the wearer about different events. Butted up next to the taptic engine is a speaker. The two are probably packaged together because when combined with subtle audio cues from specifically engineered speaker driver, the taptic engine is designed to make a special kind of motion.
There are several other components attached to the inside edge of the watch case. One of them is an antenna assembly that's on a flex circuit type material and probably handles the Wi-Fi and Bluetooth transceivers. The mechanical button is also positioned on the side of the case along with the diagnostic port. Most of the electronics on the Apple Watch sits within a 26 by 26 millimeter motherboard. We say it sits within the motherboard because the whole board and all the components are overmolded with a special packaging compound that includes silica or alumina spheres suspended in a resin. And this overmolding makes it impossible to see all but one of the board components. Nor can the overmolding be removed with chemicals you might ordinarily use to remove conventional IC packaging if you want to get a better look at the chip die. That's too bad, because the board reportedly contains more than 30 components and includes the Apple application processor that runs the whole watch. So we couldn't actually look at the individual chips on the board except for one, which sits outside the overmolding material. That chip is from STM and holds a 3D digital gyroscope and accelerometer.
For this teardown, we had to be content with removing the board, which wasn't easy, and eyeballing what we found underneath it. With the board out, you get a view of the electronics used for wireless charging and a heart rate monitor. There's one chip visible on the back substrate. It is a precision low-noise amp from Texas Instruments that we might surmise handles the ultra-low signals that are involved in sensing the wearer's heartbeat.
The back of the substrate contains what appears to be light sensors and LEDs used in sensing the wearer's heartbeat. The Apple Watch uses the same technique as the Fitbit for sensing heartbeats. The measurement technique is called pulse oximetry, although Apple has its own name for it, but it really is just pulse oximetry. It takes advantage of the fact that oxygenated and deoxygenated hemoglobin have different optical properties. With every heartbeat, there's a spike in arterial oxygenated blood, which is detected as a change in the absorbance or reflectance of green LED light. So the optical sensors measure the amount of LED light reflecting from the blood under the wearer's skin. The reflectance is a bit different during a heartbeat, and the sensor will detect this periodic signal from which the heart rate is extracted.
With the lower substrate removed, we see the back of the aluminum watch case and the optics involved in the heart rate detection. Also, there's a magnet that holds the watch to its wireless charging cradle. And that's about it. For more teardown videos, go to eeworldonline.com.